Well, welcome to LabVIEW. I'm assuming that this is perhaps the first time that you've encountered LabVIEW, and I'll walk you through some of the major points. So I'm starting up LabVIEW, and we have a variety of things we can see on the front panel. I'll go ahead and select blank VI to start creating a new VI. We have the so-called front panel. We also have the block diagram. We can look at both at the same time using Control T. I'm going to point out that the options that I'm using to create my block diagram are shown right here. A couple of those are critical. Those are being flagged as we speak. I'd encourage you to pause and adjust your LabVIEW version to match. So I will begin by placing what we would call a control on the front panel. This is called a numeric control, and then we see its representation on the block diagram appear simultaneously. Another type of numeric control would be a knob. I can double click and then type in a new name for that numeric control, and I'll just rename these to A and B. Now on the block diagram, supposing I wanted to do some operation with these two values from the front panel. Specifically, I'll just add A and B together. Well, back on the front panel under numeric, we also have things that are called indicators, and I'll use the gauge indicator specifically. And then let me connect the gauge indicator, which I'll also rename Y. I'll connect that to this addition device, which generically we refer to these as nodes. Now when I run my virtual instrument, or VI, we don't see anything happening because I'm basically adding 0 plus 0. Alright, there we have 0 plus 3. We see that indicated here. Now notice that I can adjust my knob position, rerun it. The value is recalculated, and then that value persists at the conclusion of the run. Let's try highlighting the execution so we can better see the details of how data moves through the block diagram. So you see values emerge from the controls, pass through the addition node, and we see an output being generated. Now you'll notice that I can change my inputs, and we don't see any change or associated change in the output until we actually run it. So we run it one time, and then it stops, and then we're done. Supposing we would like to actually make this calculation more of a continuous nature. I'm adding what's called a while loop structure, and it's kind of like it implies. We say run this portion of the block diagram while some condition is either true or false, depending on how you set up the loop. If I right-click and select a control, then that gives me the default, which is this stop button. Notice now that I can vary my inputs, and we see the corresponding change in the output. And this will keep working for us until we hit the stop button, which will cause the while loop to terminate. Let's turn this off so we can run it at full speed. Okay, perhaps the problem here is that this is railed out at 10, and I had A set to a larger value. Alright, now we see that the output continuously responds as we vary the knob. Nice feature here, I can double click and specify a new range setting for my indicator. Let's try making that larger. Let's also try making this a little bit bigger as well. Hey, that's working pretty good. Now, sometimes you might find that you don't actually need to run the loop at full speed. And what I'm placing here is a time delay mechanism, and that has units of milliseconds, so that's actually half a second right now. So now the loop has this half-second delay built in. We can see that the output doesn't respond any faster than twice a second. If I create an indicator for my so-called loop iterator, some people might call that a while loop index, I guess, but LabVIEW calls it an indicator. Now as it runs, we can see the progression of that while loop. And so that tells us how many iterations we've experienced so far. Now I'll go ahead and remove my while loop structure and then also get rid of some of these extraneous features here. I'm simply click and drag with my mouse and hit delete when I'm done. I'll point out another option, much less used. This is called run continuously. You notice that we're not using loop. And then this is the abort button, abort execution up here. The method that I showed earlier with the while loop is actually much preferred because abort execution is kind of like it sounds. It's not actually doing a smooth stop in the way that it was with the while loop, but rather it literally says abort execution now, and it's like doing a hard stop on the program. Perhaps not unlike doing Control-C in some other types of programming environments. Especially for applications that are intended to do things like memory cleanup and so on at their conclusion, we really generally try to avoid using that stop button if possible. So the while loop technique is the best way to set up the continuous behavior that we wanted. So that's our quick introduction to the basics of LabVIEW.